Science, my friend, is an infinity puzzle. There's always a missing piece and the puzzle never ends. In the previous videos, you've seen how challenging it was for scientists to figure out the structure of atom. What Thomson's model couldn't explain, Rutherford's did. And where Rutherford's model failed, Bohr's model came along. Bohr's model explained that electrons in an atom revolve in specific energy shells around a positively charged nucleus. It finally seemed like the structure of atom had successfully been deciphered. But not for long. Scientists still didn't know what was inside the nucleus. They were aware that it contained positive charges but weren't sure whether these were particles. Consequently, Rutherford and other scientists discovered that the positive charges in the nucleus were in fact particles. Rutherford named them protons. Scientists studied the properties of these particles in detail. It was found that protons are identical to a hydrogen nucleus. Now, what is a hydrogen nucleus? Well, a hydrogen atom contains one electron and a nucleus. Hydrogen nucleus is simply the hydrogen atom minus the electron. Its mass is close to 1 U and it has a positive charge. So just like the hydrogen nucleus, the protons inside the nucleus are also almost equal to 1 U in mass and have a positive charge. These protons together make up the mass of the nucleus. Let's see how protons differ from electrons now. The mass of a proton is almost 1 U and it is almost 2000 times that of an electron. Comparing the two, we can say that the mass of an electron is negligible. Therefore, the mass of an atom is mostly contributed by the nucleus and not the electrons. So we can simply find atomic mass by adding the masses of all the particles inside the nucleus, right? Okay, moving on, let's compare the other properties of protons and electrons. A proton has a positive charge of 1.602 into 10 raised to minus 19 coulombs. Coulomb is simply a measure of electric charge. Here's the magnitude of the negative charge of an electron. Now, as you can see, it is equal to that of the proton, but opposite in charge. Now, since the charges of the proton and electron are equal in magnitude but opposite in sign, we take them as +1 unit and -1 unit for convenience. Well, if you pick the atom of any element, you'll see that the number of protons is always equal to the number of electrons. This confirms that an atom is neutral. So now we know that protons happily reside in the nucleus while electrons revolve around it. But that's not the end of the story. When scientists estimated the atomic masses of different atoms, they realized that the masses were more than expected. For example, a carbon atom containing 6 protons should have an atomic mass close to 6 U. But the mass was actually found to be 12 U, double of what's expected. Scientists were lost. Wouldn't you be baffled too if you weighed double than what you expected? Scientists couldn't figure out where the additional mysterious mass of an atom came from. They started exploring the cause and lots of theories began floating around. At that time, Rutherford guessed that there might be something other than proton in the nucleus that was responsible for this mysterious mass. We'll talk about this mysterious mass and what it has to do with the atomic structure in the next video. But for now, let's simply sum up what we've learned about the atomic structure. An atom consists of positively and negatively charged particles. Positively charged particles are called protons. The mass of a proton is close to 1 U and the charge is plus 1.602 into 10 raised to minus 19 coulombs. Negatively charged particles in the atom are called electrons. They have negligible mass and a charge of minus 1.602 into 10 raised to minus 19 coulombs. For convenience, the charge of a proton is taken as plus 1 unit and that of electron is taken as minus 1 unit. In a neutral atom, the number of protons is equal to the number of electrons. That was all for this session. Stay curious and we'll meet again soon to know more about the atom.